Okay, so today's video we're going over section 1.6 on page 31 in your textbook. And it's talking about two-dimensional figures. So the first thing we want to talk about is a simple curve. So a simple curve is something that you draw. It's a continuous set of points that you can draw without lifting up your pencil. So this would be a curve, right? This is a curve. This is a curve, right? Also a curve. So anything I can draw without having to pick up my pen is a curve. But more specifically, we have different types of curves. So the first one I'm going to draw is a simple curve. So a simple curve doesn't cross over itself. So this would be a simple curve. Right, this would also be a simple curve. So there's no like loops. The line doesn't go over itself at any point. We also have a closed curve. So a closed curve starts and ends at the same point. So like this, right? It's closed in, right? Anything like this. But I start and end at that same point, right? That makes it a closed curve. And then we can combine those to a simple closed curve. Right, which is kind of like this one above, where it doesn't overlap itself, but it stops and ends at the same point. Would be a simple curve, or a simple closed curve, excuse me. All right, so the next two definitions we're going to talk about is, the first one is a circle. So a circle is the set of all points a given distance from a given point, which is known as the circle's center. So we have a circle, right? So, and we have a center point in the middle. So all of the points on my circle are going to be the exact same distance from the center, right? So that's what makes it circular, is that it's the same distance all the way around. And a radius is any segment that's drawn from the center to the edge of the circle. So that would be a radius, right? But I could also draw it here, or there, right? Anything from the middle to the edge of the circle, right? That should be a straight line, but my drawing skills are lacking today. Right, so that's a circle and its radius. To name a circle, we name it with the center point. So let's say this is C. So this would be circle C, right? So the notation for circle is just a circle with a dot in the middle. And then the radius is just a segment. So the radius is segment CB. Okay, and next we have polygons. So a polygon is a simple closed curve that's made of only line segments. So simple closed curve made of straight line segments. Right, so things like triangles, squares, rectangles, hexagons, pentagons, decagons, anything like that would be a polygon. Right, if I wanted to draw a star, right, also a polygon because it's made of all straight line segments. Something that has anything that's curved in it is not considered a polygon. So something that's drawn like this, right, this would not be a polygon because of this curved piece right here. Right, it has to be made of straight line segments to be considered a polygon. Right, so a circle is not a polygon, right, because it's rounded. Okay, so again, it has to be a simple closed curve, so no overlapping. Has to connect ends to one another, right? So while this is made of line segments, they don't come together, so it's not a polygon. Right, so all of these would be considered polygons. We have lots of different types of polygons, and they're named by their number of sides. Right, so this chart is in your book on page 32. I am going to expect you to know these. So you need to know that the name for a triangle, so for three-sided polygons, triangle, 4 is quadrilateral, 5 is pentagon, 6 hexagon, 7 heptagon, 8 octagon, 9 nonagon, 10 decagon, 11 is hendecagon, 12 is dodecagon. And anything bigger than 12 is just an n-gon. So like n being the number of sides. So say we have a 15-sided polygon, right? I'm not going to draw a 15-sided polygon, but so that would just be a 15-gon. If we had a 100-sided polygon, it would be a 100-gon. So you will be expected to know these for your test. So make sure that you study them. Okay, so we can also more specifically talk about types of polygons. So an equilateral polygon is a polygon where all of the sides have the same length. So they're made up of congruent line segments. So common ones like that would be an equilateral triangle, right? So all of the sides are the same length. Squares are equilateral, right? Because all 4 are the same length. Anything that you draw where all of the sides are the exact same length is an equilateral polygon. An equiangular polygon is where all of the angles have the same degree measure. So for these examples that I've drawn, all of them do have the same angle measure, right? Squares are made of right angles. All of these triangles have congruent angles. This one does not so much have congruent angles the way I drew it. But you would have to measure the angles to know if they are congruent. And then you have a regular polygon. So if something is regular, it's both equilateral and equiangular. So it meets both of those qualifications. Okay, to find the perimeter of a polygon, you just add up all of the sides. So in this case, we would add, to find the perimeter, we would do 4 plus 10 plus 8. Right, which would give us a perimeter of 22. So perimeter is the distance around, so you just add up all the sides. Okay, in the last part of this video, we're going to talk about some different parts of a circle. So a chord of a circle is any segment whose endpoints are on the circle. So like this would be a chord. So let's say it's segment AB. A diameter is a chord that goes through the center of the circle. So if our center is here, right, a diameter has to go through the middle of the circle. Okay, and then lastly we have an arc. So an arc is just a curve that's part of the circle. So like this part here that I'm going over in yellow, right, would be arc AB. So to write the name of that arc, it's just AB with a little arced line over top of it, right? Chords and diameters are still segments, so you write them the same way. So you have AB with a line over it, diameter is CD with a line over it. But an arc would be any curved part of the circle. Okay, and that's all the notes you need for today's assignment. For numbers 7 to 12, just worry about classifying the polygon. Don't worry about the convex-concave part. We will go over that together on Monday. So just worry about saying if it's a polygon and tell me why or why not.